Okay, two of them has been mentioned before. So what are those?
Refraction.
Refraction.
Okay, yes, Amanda. One is refraction. Okay, what else?
Reflection.
Okay, yes, Javier, reflection. Okay, we still have two more. So we have
Dispersion.
reflection. Yeah, another.
Um,
Another. I'm giving you clue.
Not dispersion, teacher.
Diffraction, yeah.
Okay, yes. Is it Amanda?
Yeah.
Okay, yes, it's diffraction. That is correct. Okay, last one.
Intensity.
Last one.
Intensity, yeah, sure.
Okay, what's the last one?
No idea, teacher.
Interference.
Interference. Whose voice is that? I didn't recognize.
Theory,
Who?
teacher.
Oh, Thierry. Okay, yes. Thank you, Thierry. So the last one is interference. So these are the four characteristics of light. You already know what reflection and refraction are. So for diffraction is the ability of light waves to pass through slits or barriers. All right. So how is that? So for diffraction, so let's try to illustrate. So for diffraction, so let's assume a source of light. For instance, this is the source of light. And then let's illustrate light as waves instead of particles. Okay. And then we assume a barrier. So let's say this is the barrier. And let's assume that this barrier has a slit. So it's just a tiny slit. Okay. Now, so let's say here are the wave fronts, as we describe light as a wave. So let's say this is the wave front emitted by the source. So when this wavefront strikes a barrier, the barrier will be acting as a surface. So what will happen? We expect light to reflect, so it will bounce back as how we define reflection. But if there is a slit, okay, this is what is going to happen with the light, with the wavefronts of light. So at the slit, it will create a new pattern of wavefronts. So it's just like the light passed through the slit normally. Okay, so this ability of light to pass through that slit is diffraction. Okay, you can see effect of diffraction when you do this to your finger. You try your fingers to be slightly apart. They must be very close, but not exactly.
Buka video tu pintu. Buka mic juga.
All right, but not exactly touching each other, and then face your fingers in a lamp, or let's say fluorescent lamp, and then try to look between the slits, and you will see like some shadow joining your fingers. Even the fingers are not touching each other, but there is like some shadow formation that seems connecting the fingers. Okay, so that effect is due to diffraction of light. Okay, so that's one way to see this characteristic of light, which is diffraction. All right, now how about interference? So when we say interference, uh, so okay, so interference is, so it happens when two or more waves overlap each other. So it occurs if when two or more waves have this overlapping okay, with each other. So for interference, let's say, so that's number 4. Okay, so assuming we have the same source of light, okay, we have the same barrier. So the same source, the same barrier, um, and then we describe the waves from from the source to be like wavefront. Okay, but we will be having not just one slit, but let's okay, so let's have this. So instead of just one single slit, let's assume that we have double slits in here. So these are the double slits. Okay, and then in each slit, we expect diffraction of light. So here we had diffraction. So this will be the formation of new set of wave fronts in that slit. Okay, and then since it's double slit, so we also expect diffraction in here. So there will be formation as well of new wave fronts. And as you can see in the diagram, there are certain points in the wave fronts because of the diffraction at in each slit to have intersection of the wave fronts, and that's the overlapping of the waves. So those portions are describing some overlapping. Okay, and we call that as interference. Okay, so that is interference in a water wave. You can see interference when water wave from different directions, for instance, meet. Okay, so there will be some effect when these waves, let's say there are two tidal waves, they meet each other. Okay, so there will be interference. For light, we can see it this way. Now, there are two things that would happen to the energy as light waves or even some other transverse waves interfere, or even sound wave as well. So the first one is called uh, constructive interference, while the second one is destructive interference. So how do we compare destructive interference with a destructive interference? If you have or in a constructive interference, so assuming that you had these waves, so let's say this is wave A. So assuming that this is wave A, and then this will be uh, this will meet another wave. So let's call it wave B. And then let's say these waves are of the same wavelengths, same amplitude, the same frequency. Okay, now what will happen uh, if they meet? So this is what we expect to happen to the two waves. Okay, so how do you describe the output of the combined waves? How do you describe the output?
Longer.
I'm sorry, Amanda.
They become longer.
The which one becomes longer?
The height of the waves.
Okay, or we call that amplitude. Okay, yes, the amplitude increases. Uh, the the what do you call that? The wavelengths become shorter because the frequency becomes higher compared to the original waves that interfere. Okay, so in this interference, it increases frequency and amplitude, thus the energy is increased. Okay, that's why we call it a constructive interference. So there are some interference here that could be constructive. There's this increase in the energy because the amplitude increases. Okay, now how about in destructive interference? So in destructive interference, you still have the same, for example, the same waves of the same frequencies and wavelengths, amplitude. Okay, but what will happen once they interfere each other? So this uh, could be the result. And how do you describe it compared to the original?
It is longer.
The wavelength becomes longer. What else?
Mm.
Lower
The
energy.
amplitude is lower.
Yes, the amplitude is lower.
Lower
So how do you
frequency.
lower frequency? Yes. So you only generate few waves per second. And at the same time, how do you describe the energy it carries from point to point?
Lowest energy.
Lower, yes. So it's now carrying lower amount of energy. So from the name itself, destructive. Okay. So these are the two possible things that would happen when waves interfere. Okay. So these are all the four characteristics of light. Okay. So from reflection until interference. Now let's just focus on reflection of light. And you already know the definition of reflection of light. So it's just about bouncing of light when it strikes a surface. Now, reflection of light has two types. Could you tell me the two types of reflection?
Regular and diffuse.
Okay, yes, that is correct, Jaya. So we have regular reflection and diffused reflection. So let's enumerate here. reflection, and we have diffuse. Okay, how do you compare the surface in which regular reflection occur and diffuse reflection occur? So how do you compare the surface in which light strikes?
Is it one smooth
For
and one rough?
yes, one is rough, and which one is rough?
Diffuse, I think.
Okay, yes, that is correct. So in diffuse reflection, it occurs in a rough surface, while in a regular reflection, it occurs in a smooth surface. How about the formation of the light rays in a regular reflection and diffuse reflection? So how do you compare the direction of the light rays that are reflected back in a regular and diffuse? Anybody? How do you compare the light rays for regular and for diffuse? The formation of the light rays. Okay, so for regular, the light rays are, or the reflected rays are what?
Straight in the same angle.
Um, s- straight with the same angle. Okay, yeah, actually that makes sense. Or shall we say, okay, so in regular reflection, so the light rays that are reflected from the surface are parallel to each other, while in diffuse reflection, the light rays are in random directions. Okay, so if we compare the reflection in a regular surface or in a smooth surface and in a rough surface, so we can illustrate it this way. All right. So from the source, light rays are parallel, but when it strikes a smooth surface, they are still parallel. So we call that regular reflection. So how do you describe the image formed in the surface when the reflection is regular? How do you describe the image form? Let's say you look at the surface. If the light rays are parallel, the light rays reflected, okay, by the surface are parallel, what uh, what do you see in the surface? How do you describe the image?
Clear image.
Okay, yes, it produces a clear image. And if in diffuse, because the directions are random, so the image will be blur. Okay, so it will be blur because light rays are pointing at different directions. So that's the difference between regular and diffuse reflection. Now, reflection of light is governed by a certain law, which we call the law of reflection. And there are two parts mentioned in the law. Okay, in the first part, okay, I want you to identify the missing here, huh, in the paragraph. So for the first part of the law of reflection, the blank, and the blank lie on the same plane. Okay, could you identify the three important terms to complete this law? What are those missing terms here? Okay, who would like to give the answers for this? So what are the three missing words here to complete the law of reflection? The first part of the law of reflection.
The incident and the reflected. Okay.
Okay, yes, so those are some of the terms here. That is correct, Javier. So we have the incident ray. So that's the first. We have the incident ray. Okay, next we have the reflected ray. And what's the other missing term here?
Normal.
Yes, that is correct, Jaya. We have the normal. So the incident ray, the reflected ray, and the normal lie on the same plane. What does it mean? So let's say this is a surface. So let's say a mirror, and then we have the point source of light. So assuming this is the point source. Okay, and then so let's say this is one of the light rays emitted by the source. So that light ray will be striking the surface from the source. Okay, and then after that, it is expected to bounce. Okay, so what do you call the light ray from the source to the surface? What do you call that light ray from? Incident ray. So we call this the incident ray. So we denote it with the symbol I. How about from the source to another direction?
Reflected rays.
Reflected ray. Or we denote it with the symbol R. Okay, and then we assume a line perpendicular to the surface. So it's a line that bisects whatever angle from the incident ray to the reflected ray. So it's like an angle bisector. Okay, and since it's just an imaginary line, we use broken line to represent. Now, what do you call that line?
Normal.
Yes, that is correct, Jeffrey. We call that the normal. Okay, let's continue. And we denote it with the symbol N. All right, now let's go back to the law. It says here that the incident ray, the reflected ray, and the normal lie on the same plane. Like in this case, our plane is a mirror. Now, in this law, it's impossible that, let's say, you have two different planes or surfaces. So, assuming this is surface A and you have surface B, and then let's say this is the incident ray or the light ray from the source, which strikes plane A, and then the reflected ray will be appearing on plane B, for instance. So plane A reflection is plane B. This one is impossible. Okay, why? Because according to the law, these rays, the incident, the reflected, and the normal, they must be at the same point in the plane. So that's at the same plane. And what do you call that point in that plane in which these three are expected to be together. What do you call that very point in the plane? It's point of what?
Reflection.
Point of reflection. Another. So that's the point of, okay, we call that the point of incidence. Okay. So these three must be appearing at the same point in the plane, which we call the point of incidence. It's impossible that they are appearing at different points in different planes. Okay. So that's what the first part of the law tell. Okay. So they must be lying on the same plane. Next, for the second part of the law, so I want you to complete again the statement. So for the second part of the law, the blank is equal to the blank. Okay, what are the missing terms here?
Angle of incidence and angle of reflection.
Okay, that is correct, Jaya. So we have the angle of incidence. Let's label here. Okay, so we have the angle of incidence is equal to the angle of reflection. So they must be equal. How is that? Um, we have an angle from the incident ray to the normal. So this one. What do you call that angle?
Angle of incidence.
Yes, we call that the angle of incidence. So we denote it with the symbol theta I. So we call that the angle of incidence. And then we have another angle from the normal to the reflected ray, and that is the angle of reflection. This one. Okay, so that's theta R. And according to the law, theta I must be equal to, so theta I has to be equal to theta R. They should always be equal. Okay. Is this applicable to diffuse reflection? That the angle of incidence is equal to the angle of reflection? Because in here we can easily tell, as both the reflected rays and the incident rays are parallel, we can easily tell that the angle of incidence is equal to the angle of reflection. But how about in diffuse reflection? Are they equal?
Yes.
Okay, yes, they are still equal because the normal in this type of reflection are also in a random direction. So for this incident and reflected ray, this is their normal. For this one, this is the normal. So as you can see, the normal are also in random directions. But those normals are in random directions, we can say that their angle of incidence and the angle of reflection are equal. Okay, so they are still equal.
Sure, I want to
So,
ask.
yes,
Uh,
Javier.
is the angle of reflection plus angle of incidence equal to 90 degrees, or is it random?
Uh, should it be equal to 90 degrees? Well, as you can see here in the diagram, angle of incidence and angle of reflection are acute angles. So they are less 90 degrees.
Okay, thank you, teacher.
But in a refraction of light, so here, in a refraction of light, the angles could be equal to 90, and it can exceed 90 degrees. So we will find out what some physical phenomena could have equal to 90 or more than 90-degree angle. Okay, but in reflection, they are acute angles. Okay. Okay, are there some more questions? Okay, so next meeting, so we will have some calculations involving the law of reflection, and then if we have remaining time, we can continue some review, okay, in preparation for your test. So that's all for today. You may now proceed to your next subject. Goodbye, class.
Fine, thank you, teacher.
Thank you, teacher.
Thank you, teacher.
Thank you, teacher. Teacher,
Okay.
I have a question.
Goodbye, thank you, teacher.
Yes, what's the question?
Is our chemistry test really on this Thursday? Because for this Thursday, we already have 3 tests scheduled on that day.
What are those subjects?
We have Physica, Bina, and Math.
What are your Physica and Kim and Bina? First monthly test or second already?
First.
It's just the first.
Yes.
Oh, I thought they already had their monthly test weeks ago.
No.
Is it just your class or even the other class? Because they didn't ask me a while ago.
I'm not sure about the other class, but I'm pretty much sure their Physica is held at the same time as ours. For the Math and Bina, I'm not that sure, teacher.
Okay. Wait. How many times is your Bina per week?
Once.
Once a week. How about your how about your Physica?
Physica is twice.
Twice. Okay, wait. Okay, I will try to arrange first. Okay, then
Yeah.
I will give you an update. Okay, anyway,
Okay.
thank you for informing me. Okay.
Yes.